Hello all. So we are in the module 2 and the last lecture we have covered sign test. We have seen that where and how sign test can be used. Also we have done a couple of problems which are solved by using a sign test. So this lecture is a continuation of sign test and we are going to introduce one more advanced test of location which is called Wilcoxon sign rank test. Okay, let's start the journey. So the concept covered in this lecture, we are going to have one more problem. Of course, it is a two-sided problem and which is going to be solved by sign test, and then we will introduce Wilcoxon sign rank test and we will study the basic properties of Wilcoxon sign rank test, and one problem we are going to solve by using Wilcoxon sign rank test. Okay, so in the last lecture we dealt with left tail test and the right tail test, but we haven't touched two-tailed test, right? So what will be the strategy when your alternative is two-tailed? How do you use sign test in this case? Let's have one problem. Let there be a data set on the length in centimeter of a sample of 10 randomly selected pygmy sunfish. The data is as follows, as you can see: 5, 3.9, 5.2, 5.5, 2.8, 6.1, 6.4, 2.6, 1.7 and 4.3. Can we conclude that the median length of pygmy sunfish differs significantly from 3.7 centimeter? Now I would ask you to look at the question, because question is the key to form your alternative hypothesis. In the question, perhaps you have noticed the verb is differs. That means the alternative hypothesis should be formed in the format of two-sided. Clear? So assuming the length of pygmy sunfish comes from a continuous distribution with median mu, next we are going to construct the null hypothesis and the alternative hypothesis. So what is the median? Can you see the median value under the null hypothesis? Yes, it is 3.7. So null hypothesis is mu is equal to 3.7 against the alternative hypothesis mu not equal to 3.7. And in our last lecture I told you that when your alternative is two-sided, then your rejection will be coming from the both tails. One rejection will be coming from your right tail and another rejection will be coming from the left hand side, right? So first you have to calculate the number of positive signs, that means number of observations which are bigger than the null hypothetical median value, that is 3.7. So how many observations are really greater than 3.7? As you can see that 6 observations out of 10 observations are greater than 3.7. Now these are R means number of positive observations, follow binomial with n is equal to 10, the first parameter of binomial distribution, and p is equal to half, probability of success is equal to half under null hypothesis. We reject null hypothesis if r greater than r alpha by 2 or r less than equal to r alpha by 2 prime. Now what is alpha? Alpha here is your level of significance, and generally we consider equal tail probability or equal tail rejection region. So in case you are considering alpha as 0.05, alpha by 2 comes as 0.025. So your right tail rejection probability will be 0.025 and your left tail rejection probability will be another 0.025. Clear? Now you can see the picture. Here I have drawn one alpha by 2 and another alpha by 2 is there. You have to figure out both of r alpha by 2 and r prime alpha by 2. One is from the right hand side and another is from the left hand side. and you know the probability structure to figure it out. Probability r greater than equal to r alpha by 2 less than 0.05 by 2, that is 0.025, and probability r less than equal to r alpha by 2 prime, that is also less than equal to 0.025. Okay, so 0.05 divided by 2, which comes as 0.025. Let's find r alpha by 2 and r prime alpha by 2 using R code. You people are already aware of the R code. In the last lecture I taught you that by the command dbinom one can figure out any probability mass in the binomial distribution. So what I am doing, r prime alpha by 2. So first I am starting from the left hand side. So what is the smallest number of success, I mean to say, that is 0. So what is probability r less than equal to 0? That is 0.0009. Now you can ask me that how did I find this number? This number you can find by using this command line dbinom number of success. The first argument is the number of success, the second argument is the total number of trials, and the third argument is the probability of success. And we can see that 0.0009 less than 0.025, then take 1. What is the cumulative probability of r being less than equal to 1? In that case we have to add r is equal to 0 and r is equal to 1. The together probability will come as 0.0107, which is still less than 0.025. Now can I be able to include one more point in my rejection region? Let's have a check. So take r is equal to 2. What is the cumulative probability r less than equal to 2? You can see the cumulative probability r less than equal to 2 comes as 0.0546. Clear? And 0.0546 is greater than 0.025. So when it is greater than 0.025, that means this point is falling inside the acceptance region. So this is the acceptance region, okay, and these two tails are denoting the rejection region. So we cannot take 2 in my rejection region, to be more specific, in my left tail rejection region. Similarly, think about the rejection from the right hand side and start from the largest value of r alpha by 2 from the right side. So what is the largest value for a binomial distribution? The largest value of success is 10. So what is probability r greater than equal to 10? Okay, only 10 will be there. So r is equal to 10. If I write probability r greater than equal to 10, which means essentially I am writing r is equal to 10, and that comes as 0.009. It is a symmetric binomial. So you might notice that r prime alpha by 2 is equal to 0. It has the same probability as the probability taken by r is equal to 10. So similarly, include one more point in your right tail rejection, that is 9. So probability r greater than equal to 9. How many points? That includes r is equal to 9 and r is equal to 10. So altogether probability comes as 0.0107, which is still less than 0.025. Clear? Now if we include 8, it again enhances the cumulative probability over our fixed alpha by 2 level, which is 0.025. So we cannot include 8 here. So what are the critical point? Finally you can see from the left hand side critical point is 1, and from the right hand side critical point is 9, and What is your R calculated, which you have counted right from the data set given? It is 6. So you can see 6 lies within 1 to 9. That means it falls inside the acceptance region. Basically, we reject the null hypothesis if R calculated less than equal to 1 or R calculated greater than equal to 9. But what we can see here, in our case, R calculated is just 6, which falls inside 1 and 9. Therefore, we fail to reject the null hypothesis. Median length of pygmy fish is 3.7. That will be your final conclusion. So, in this way, you can handle two-sided alternative hypothesis using sign test. Now, in the sign test, what you have seen, that we are using just the positive sign and the negative sign, right? What happens along with the sign if we include the magnitude of the distance? That means one observation, how much positive it is, how much negative it is. That means the distance. Distance from what? Distance from the median under the null hypothesis. In Wilcoxon sign rank test, which is again an advancement of sign test, we are considering two factors. First one is the sign of the observation, whether it is a positive observation or negative observation, as well as we are looking at the distance of the observation right from your central value, and in this non-parametric test the central value is mu0 or median under null hypothesis. So, sign test does not consider magnitudes of the observation, it just uses the sign of observation. A larger positive observation greater than null hypothetical median does contribute the same as a smaller positive observation. Look at the pygmy fish example, just now we did that example. With respect to mu median 3.7, the observation 6.4 and 3.9 are both positive, both are greater than 3.7, although their distance from the median value are different. One is 2.7 and another is 0.2. How did I find it out? Just subtracted 6.4 minus 3.7 and 3.9 minus 3.7. So, Wilcoxon sign rank test address these magnitude or the distance issue not only by the direction of the observation but also considering their magnitude of the distance. This test is more efficient than the sign test for testing median of the distribution. Let x1, x2, xn be n random and independent observations from a continuous distribution. I told you never forget this assumption while dealing with test of hypothesis under non-parametric methodology. So, we test h naught mu is equal to mu 0. We consider distance of each observation under h naught, and di means for the distance. Okay, di means for the distance, and how did you find out di? That is xi minus mu 0. These distances come from a continuous distribution which is symmetric about 0. So, that is another part of Wilcoxon sign rank test. Another part means another type of assumption that when you are calculating di's, all these di's, of course these are random variables because you are using random variables in finding out di. So, these distances are following a symmetric distribution about 0. Therefore, positive and negative di with the same absolute value have equal probabilities to occur under the null hypothesis. So, we can write probability di greater than 0 is equal to probability di less than 0, that is equal to half, and it comes straight down from the definition of median. Next, we rank this absolute difference. So finally we figure out di, and then we will find out modulus of di, means absolute figures of di, and we have to make the ranking of these absolute difference from smallest to largest. And finally Wilcoxon sign rank test statistic is T plus, it is the sum of the ranks of the positive DIs, okay, positive DIs. Quite obviously T plus has a conjugate statistic which is T minus. That is the beauty of Wilcoxon sign rank test. Once you are calculating out the sum of the ranks for the positive DIs means for which the observations are smaller than the null hypothetical median value. Clear? So what I am trying to say, if you have T plus, then on the contrary, on the flip side, you will have T minus. T minus is the sum of the ranks of the negative DIs. So for a set of n observations, sum of all possible ranks, suppose you have n observations, so what are the possible ranks? 1, 2, 3, 4 till n. So what will be the sum of all possible ranks? That will be 1 plus 2 plus 3 plus till plus n. So it is n into n plus 1 by 2, and this n into n plus 1 by 2 is equal to T plus plus T minus. That means if you find T plus, then finding T minus is extremely easy, because T plus and T minus are linearly related. Okay, the extreme value of T plus are 0 and n into n plus 1 by 2. Okay, either T plus can be 0 or T plus can take all of the observations are positive. Therefore the maximum value of T plus can be n into n plus 1 by 2. At each observation might have either positive DI or negative DI. That means total number of positive and negative assignment will be 2 to the power n. How does it happen? You have n observations. So for n observations you have n DIs, right? So DI can be positive or negative. Under null hypothesis, being positive is half and being negative, the probability is another half. So basically plus minus plus minus plus minus. So 2 point sample space you are combining. Therefore altogether you have to deal with 2 into 2 into 2, 2 to the power n assignments. So what are the mean and variance of this T plus? T plus is our test statistic and we call it by the name of Wilcoxon signed rank test statistic. Let us define an indicator function Zi, which is either 1 or 0 if Di greater than 0 or if Di less than equal to 0. So T plus, which is the sum of the ranks of all positive DIs, we can write that as summation Zi and Ri. Ri is the rank of ith observation. You might have noticed when Zi is 0, that means when we are dealing with negative observation, that will not give any contribution in the formation of T plus, right? So under H naught, these Zi's are independent and identically distributed Bernoullian random variables with probability Zi is equal to 1 and that is equal to probability Zi is equal to 0 and that is equal to half. How come it happens? Because it depends on the structure of Di, right? Because probability Di greater than 0, that is half, and probability Di less than equal to 0, that is also half. So Zi is depending on Di, so why not that it retain the same probabilities? So expectation of Zi is just the clear cut idea, value multiplied by the corresponding probability, and expectation of Zi comes up as half, while variance of Zi comes up as 1 by 4. typical statistical computation, nothing new in it. Therefore, expectation of T plus will be summation expectation of Zi into Ri. What is expectation of Zi? Already we have figured out, this is half, and Ri's are the rank of the observations, right? So what are the possible ranks? Just now we have told that possible ranks are 1, 2 till n. So summation Ri means R1 plus R2 plus Rn, right? So 1 plus 2 plus dot 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 plus n divided by 2, and the final answer is n into n plus 1 by 4. Similarly, upon the calculation you can figure out variance of T plus is n into n plus 1 into twice n plus 1 divided by 24. Now one question might trigger in your mind that what is the need of computing expectation and the variance of T plus? As you know that in case your sample size is quite big, if it is greater than 20, then you can convert T plus into a normal variable, that is T plus minus expectation of T plus divided by square root of variance of T plus will turn to a normal 0, 1. Therefore, we need to know expected value of T plus and variance of T plus. Let us have a very interesting topic where you will find out on your own the null distribution of T plus and T minus. How do you find out the exact probability distribution of T plus? Simultaneously T minus. Okay. So possible positive ranks, we are taking n is equal to 3. So we have 3 observations. Okay, let me write x1, x2 and x3. So for 3 observations, how many ranks can be possible? 1, 2, 3, right? So the first observation can have the rank 1, the second observation can have the rank 2, the third observation can have the rank 3. Clear? So look at the column head of first column head, possible positive ranks, DIs are greater than 0. So 1, 2, 3. That means first observation is positive, second observation is positive, third observation is also positive, and their ranks are 1, 2 and 3. So what will be the value of T plus then? 1 plus 2 plus 3, because we know T plus is defined as sum of the ranks of the positive observations. So 1 plus 2 plus 3, that is equal to 6. What will be the possible negative ranks? Is there any negative ranks? No, there are no negative ranks. So we are writing it as by nil. So the value of T minus, that means sum of the ranks of the negative observation, that is invariably 0. So number of ways to assign positive and negative DIs. So D1, D2, D3 all are positive, plus, plus and plus. Okay, plus means positive observation. Only one way you can assign, there will be one option where you will find all of the observations are positive. Is there any other way? No, there is no other way. Next, suppose the value of T plus is 5. How do you get this 5? What will be your assignment to the ranks? You have 3 observations, mind it. So the first observation is negative. First observation means the observation which has rank 1. But the second observation has the rank 2 and the third observation which has rank 3 are positive. So if you are adding 2 plus 3, that is equal to 5. So possible negative rank is 1, value of T minus is 1. T minus means once again sum of the ranks of the negative observation. So you can look at this assignment and you will find out minus, plus, plus. This is the first observation, 2 means the second observation which has the rank 2 and the third observation which has rank 3. So is there any other way you can arrange this plus minus so that the sum of the ranks of the positive observation still 5? No, there is no other way. So only one option will pop up, right? Similarly, for 4 you will have one assignment plus minus plus, but for t plus is equal to 3 there are two possibilities. The second observation is positive, the first observation, look at this assignment, it will be clearer, plus plus minus. That means first observation is a positive observation, second observation is also a positive observation, but the third observation, that is the maximum largest observation, is a negative observation. So 1, 2. So if you are summing the rank of the positive observation, 1 plus 2 comes as 3. Not only that, another thing might pop up that, well, first two observations are negative observations, but the third observation, the largest observation, is positive. So it bears rank 3. So altogether the value of t plus will be 3. Similarly, I hope that you can understand all of the assignment for t plus is equal to 2, for t plus is equal to 1 and t plus is equal to 0. What is the matter when t plus is equal to 0? That means no observations are positive. All of the observations are less than median. Di is less than 0 for all of 3. Then you can see the value of t minus is 6, but the value of t plus is 0. Can you understand that t plus and t minus are conjugate? When t plus is increasing, t minus is decreasing, and when t minus is increasing out, t plus is decreasing, right? So probability of t plus is equal to 6 is same as probability of t minus is equal to 6. See, what is the probability of t plus is equal to 6? 1, and total assignment, how many assignment one can make? You can just count it out. 1, 1, 1, 3 plus 2 is a 5, 6, 7, 8. So altogether 8 types of assignment, right? So the probability will be 1 by 8. Similarly, other probabilities of t plus and t minus are same. So if I ask you what is probability t plus is equal to 2, just have a look over t plus is equal to 2. How many options, how many favorable cases? That is 1. How many total number of cases? That is 8. So 1 by 8 will be the probability. Similarly, for n is equal to 4, distribution of t plus can be found in a very similar manner, very analogous manner. In that case, total number of cases will be 2 to the power 4, that means 16, and I am not going to explain every bit of this calculation because I am dead sure that you people are smart enough to look at it. So possible positive ranks 1, 2, 3, 4, value of t plus 10. Only glitch is what will be the range of t plus, what will be the maximum value of t plus. Since you are dealing with 4 observation, x1, x2, x3, x4, so the maximum sum of the ranks will be n into n plus 1 by 2. So 4 into 5 by 2, which comes as 10, and the minimum sum of the ranks for the positive observation, that will be 0. So these are the possible figures for t plus: 10, 9, 8, 7, 6, 5, 4, 3, 2, and for every possible figure you can find out the assignment of plus and sign, plus and minus, plus sign and minus sign, and you can count out how many options, how many ways one can form to have that value of t plus, right? Similarly, you can figure out the probability, p here means the probability of t plus is equal to 5. I have done here 5, but you can do for 8, you can do for 4, anything you can do. Moreover, from the previous calculation, it is clear, already I have noted it down, that it is clear that the distribution of both t plus and t minus are symmetric around the mean n into n plus 1 by 4. So, when we are taking n is equal to 3, that will be 3 in case previous calculation. So, the test statistics based on t plus and t minus provide the equivalent test rules. That is very important. That means one test you can solve it by t plus, or you can make the rejection region on the basis of t minus. Suppose you are doing a right tail alternative, which is H1 mu greater than mu 0. Okay. So, for right tail alternative, what we can expect? We can expect that count of positive DIs will be higher, leading to the higher value of t plus, right. So, when your alternative is giving you the idea that your median is bigger than the null hypothetical median, what we can expect? We can expect the positive observations are higher. If they are higher, their ranks will be higher, which in effect will yield the value of t plus will be higher. That is what is written here. Then we reject H naught if t plus is too large, or equivalently, look at this word, equivalently t minus is too low. Okay? Because if what we have seen, if t plus is increasing, invariably t minus is decreasing down. Okay? So, therefore, you can make your rejection region on the basis of t minus. Manual rejection criteria is as follows. Conventionally, rejection is taken always to the left hand side. This is a conventional way of dealing the rejection region under Wilcoxon sign rank test. But when we will be doing the same test using R, you will see that there is no convention. Okay? Everything depends on the p value. Okay? But if you are looking at some conventional statistical table which has the values of t plus along with the corresponding cutoff value, then the way of rejection is towards the left hand side. So, if your alternative is a right tail alternative, then we have to figure out t minus, and we reject the null hypothesis if t minus less than t alpha. On the contrary, if you are dealing with a left tail alternative, then my rejection criteria will be based on t plus, because under the left tail alternative t plus will be smaller. So, t plus will be smaller means smaller the value of t plus, stronger is the evidence against the null hypothesis. So, rejection will be t plus less than equal to t alpha. Remember, unlike the normal test, here both of the rejection is left tail. Clear? So, when you are dealing with a two tail test, you have to consider minimum of t plus and t minus, and there again you have to make the rejection region if the minimum of t plus and t minus less than t alpha. So, these t alphas are all the critical points, and in the Wilcoxon table we will have these critical points. So, critical values of t of Wilcoxon sign rank test is available in table for different n. From there we can find t alpha. Remember, for 0 difference x minus mu 0, generally we discard the observation, we just omit the observation. For large n, as I already told you, once you know the expected value of Wilcoxon sign rank test statistic, then for large n you can convert this to an usual normal test, okay, to a usual Z test. Okay, let me show you the table. This is the formal and conventional T table. Okay, T table means Wilcoxon sign rank T plus or T minus table. Clear? So, here you can see n is the number of observations. So, 5, 6, 7 and one tailed over there, two tailed over there. Can you see alpha? So, alpha, if it is one tail, you have to go to the topmost row, clear? And if you are dealing with a two tail, you have to go with the second row. And it depends on, if I ask you that for alpha is equal to 0.05, what is the tabular value? The tabular value is for say n is equal to 7, n is equal to 7, one tail test, if it is a one tail test, the tabular value will be coming as 2, clear? And for the same 2 will appear when you are dealing with the two tail test, then your alpha will be just the half of one tail alpha. If it is 0.05, then for two tail this alpha will come up as 0.05 divided by 2, clear? So you can go to any value, these will give you T alpha, and if your T calculated less than T alpha, T plus or T minus or minimum of T plus T minus less than T alpha or T alpha by 2, then you reject the null hypothesis. That is how the manual way of testing by Wilcox and Sein-Rank strategy can be done. So for having this, you can go through the Gibbons book, as I have already told you, and also Fundamentals of Statistics by Gun Gupta and Dash Gupta. In my next lecture, you will learn to solve few problems both manually and by using R. So that's it, and thank you so very much.